Hello, welcome back to Mastering Statistics. We're doing hypothesis testing, two variances, two-tailed tests. This is the second problem. Now that we have the basics out of the way in the last section, which you definitely need to watch if you haven't already, then we can do this problem and kind of speed things up just a little bit. Let's just give you the raw data for this problem. Let's say we sample from population 1, 20 people. Doesn't matter what we're studying, but we find out that their sample variance, S1 squared, 7.50. And then we go over to population number 2 and we sample how many people from population 2? 18, let's say. And let's say the sample variance from population 2 is 16.78. I don't know what this could be. This could be the variance in the grocery bill from people from two different states. This could be, Oklahoma, and this could be Florida. We take 20 people from Oklahoma, 20 people from Florida, and we get the average of their grocery bills, but we're not studying the average of the mean. We're studying the variance. So the variance from this population is much tighter, much less variance in the grocery bill that they have. And the variance from the people we sample from the other states seem to have a wider dispersion, a wider variance in their grocery bill. Okay. Now also given in the problem statement is that the alternate hypothesis is that the variance in the population 1 is different from population 2, and that the level of significance 0.10. So this is all the information I'm giving to you in raw form. Typically you'd read that stuff out of a problem. We're going to do a full-blown word problem in the next lesson, but we're going to solve the entire thing as if we had just pulled this information out of a word problem. We know how many people we've sampled from each population. We know the sample variances. We know that the alternate is written like this. So the first step we want to do is write the alternate hypothesis down again, which is the claim, right? Sigma 1 squared, the population variance is different from the population variance of population 2. Now, if that's the alternate, then the null hypothesis has to be the mathematical opposite, which means that they're equal, right? So it looks like they are different, right? 7.5 compared to 16, that looks quite a bit different, but as we've done these problems enough, you know that it all depends on the level of significance and other factors as to if it's statistically significant to draw this conclusion from the whole population. The level of significance here is 0.1, which means 90%. So what I want to do, or 90% level of confidence in our test. The next thing I want to do is go over here and write down and draw a picture of the F distribution and write down our rejection regions. And then we'll calculate the values and we'll go from there. The F distribution goes up and comes down. Now we have 0.1 here, which is the level of significance. And because we have an alternate hypothesis with not equal sign, we know it's a two-tailed test. That means half of the level of significance will be in the right tail, and the other half of this level of significance will be in the left tail. So they add up to be the level of significance, 0.1. So what this means is that over here, over to the right, we have a critical value here with a shaded area of alpha over 2. Now, what is alpha over 2? Alpha is 0.1. You divide that by 2, you get 0.05. So that's the shaded area to the right. And likewise, we have a shaded area over here to the left, which is the other alpha over 2, which is also 0.05. Okay? Now we have those rejection regions there, but we need to know what the actual values are here so that we can make our determination. Now this critical value is going to have an area to its right of alpha over 2. So we call it F sub alpha over 2. This guy is going to have a shaded region of alpha over 2 to its left, which means that the shaded alpha region to the right is 1 minus alpha over 2. So we call it F sub alpha over 2. So all that really remains in the rest of the problem is to figure out what these values of F are that divide it into the three rejection regions. So let's just refresh your memory. If the test statistic falls here, we reject the null hypothesis anywhere over there. If the test statistic falls anywhere here, we also reject the null hypothesis, and if the test statistic falls anywhere in the middle, I'll just draw it like this, and I will say we fail to reject the null hypothesis. So that divides it into our three regions. So the question is, how do we find this one? How do we find this one? All right, so we need a value of F that's going to give us an area of 0.05 to the right. So normally for left and right tail tests, we just go grab a table with the level of significance in it. But